Hello everyone. I welcome you all to the machine learning tools which are used in Python. Before I start my video lecture, I acknowledge W3 Schools for providing me necessary requirements for the explanation. Basically, machine learning tools deal with the data set. So what is a data set? Data set is a collection of data. It can be anything from an array to a complete database. It's very important. These two sentences are very, very important sentences. So, what's a data set? It is a collection of data. It can be an array, means single dimension array. It can be complicated array. It can be data which is collected from Excel sheets. It can be data which can be collected from CSV file. So the data may be in any form, and machine learning tools should extract this data for processing. It's a wonderful tool for the machine learning applications wherein you can think of the data in any form. So just look at the example given over here. Very simple example is given. 99, 86, 87, 88. What are they? It is a list. This is a list of data. Very simple data. Or I can say it's an array of some numbers. So very simple data. At the same time, you can go to a data which is available in the form of a database. So car name, color, age, speed, auto pass. See, multi-dimensional data wherein you are getting a real-time entity as a data. This could be available in the form of a database. This could also be available in the form of an Excel sheet. So in any form, a data can be available. So this is something a complicated data, or I can say it is a real-time data. This could be a real-time data which is a bit complicated in nature, whereas this is a very simple data containing your numbers. As I told you, it's an array. It can range from an array to the complete database. So everything your machine learning tool is going to handle. So normally we have various activities related to this database. By looking at the array, we can guess the average value is probably around 8 and 90, 80 and 90. And we are also able to determine the highest value, lowest value. Right? See, I look at this particular array. What are the activities I can think on this array? A very simple array. The activities, what I can think by looking into this simple array could be arranging this data in an ascending order, or arranging this data in a descending order, or taking the average of it, taking the maximum element out of it, taking the minimum element out of it, taking the sum of all these things, taking an average of all these things. See, these are all the various activities which are associated with the very simple array. See, the activities also are very limited. A couple of activities which you can think over this particular set of data. But when it comes to a database, here it's a complicated data, or I can say it's a real-time data stored either in database or in Excel sheet. What you can do? So we can look into some real-time applications, like find out of these database. One thing which you can find out is which color is more getting reflected here. That says, out of all these different colors, which color has a good market value? Is it a red color, or is it a black color, or is it a gray color, or is it a white color? See, this could be one application. So whenever a people think that okay, a real-time application, I may give an example like I'm going to buy a car. What is the most popular color which is available in the market so that I can book my car? This could be one application. So my ML tool is able to get me that answer out of all these different models, which color car is more getting sold out. Coming to year, which is the oldest car among the different cars. So you can see over here age 5, 7, 8, 7, 2, 17. VW is a car which is having 17-year-old. Then what is the maximum speed? What is the speed which a car can go? So here look into the applications. You can find out what is a more frequently used colors, which is the age, which has got more maximum age. Then whether what is the speed of the car, what's the maximum speed of the car. See here, all these are real-time activities. So machine learning here is for analyzing the data and predicting the outcome. The concept of machine learning is to analyze the available data and based on the analysis predict the outcome. That is a tool, that is a machine learning activity. It could be as simple as finding out some average ascending order, descending order, or it could be some real-time applications. I may give one more examples where I may use the machine learning tools. See, you're all predicting the weather forecast. There also we are using the same machine learning tools by taking the database of the different weather, different parameters like temperature in that area, humidity in that area, airflow, then air pressure, so date maybe for 10 days. So these are all the various data which are available in the database, which will help the machine learning tool to predict the outcome. So very important factor here is that machine learning is a tool for analyzing the data which are available and to predict the outcome based on the analysis of the data. Right? So now let us see what are the different types of data types. For analysis, we have different data types, including numerical data, categorical data, ordinal data. Let us see what are the specialities of these three different types of data. Let us take a numerical data. The name itself suggests what is a type of data. Numerical data are numbers, which can be split up into two categories. The numbers which you can split them up into two categories. What are the two categories? Discrete data, continuous data. What do you mean by discrete data? They are the data that are limited to integers and they are the counts. For example, number of cars which are passing by. I'll give you very good example for discrete data. The example is the city corporation is planning for finding out the density of vehicles which are passing in a particular road. So there is a team of people who are sitting on the side of one particular junction. Their responsibility is to count how many two-wheelers have gone, how many four-wheelers have gone from morning 9 to evening 4. How many six wheelers have gone? How many cycles have gone? See, whatever data which they collect are the examples for discrete data. So they are limited to integers. See, you cannot find the 3.5 cars which are moving. It could be either 3 car or it could be 4 car. So you cannot have 3.5 cars. So that's a discrete data. Coming to another one, continuous data. Continuous data is measured in terms of number. Number which could be integer or which could be float. For example, a measurement, it's a measuring. The data concentrates on measurement. Look at here. Measured data that can be any number. Example given here is price of an item, size of an item. I will take the size of the room. How do I take the size of the room? It says the size of the room is 3.5 meters by 4.5 meters. Say 0.5. It's a continuous data. Or any data which keeps on changing linearly. Keeps on changing linearly. So a vehicle is moving on the road. It has gone to a distance of, let's say, 3 kilometers. After 3 kilometers, 3.1 kilometers, 3.2 kilometers, 3.3 kilometers. Then it goes to 3.4 kilometers. Then it goes to 3.5 kilometers. See, between 3 kilometers to 4 kilometers, there are n number of intermediate steps, which I can say continuous data. N number of intermediate states. So, between 3 to 4, 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9, 4. But when it comes to discrete data, it is 3 and 4. So, if the 3 cars pass away, next car which is passing that particular gate is 4th car. There is no 3.1th car. So, please try to understand the difference between discrete data and continuous data. Okay, so continuous is continuous in nature, which contains real numbers, whereas discrete is an integer data, which keeps on changing in terms of numbers. But here, the data which changes in the form of step by step. It's a continuous data. It can be 3.01 also, 3.001 also. So you can have 3.01, 3.02, 3.03. It's continuous data. 3.001 if you want a more accurate result. So that could be your continuous data. Coming to next one, categorical data. Right? Categorical data where the values cannot be measured against each other. These are the data where the values are not measured against each other. Example, your color. You cannot measure a red color with a blue color. You cannot measure blue color with a white color. You cannot measure any, yes or no values. These are not measurable quantities. They are category. For example, car. Can you measure a car with a bike? No, you cannot measure car with a bike. Car is car. Bike is bike. So, the data which are categorical, the name itself is very familiar. Categories. We have got different categories. So, normally, if I want to say, when you go to shopping malls, so the items in the shopping malls are arranged category wise. You want utensils, go to that area. You want electronic items, come to this area. Even in, let us say, I'll take an example of Harsha or Girias. TVs at one side, washing machines at another side, music systems at one more side, grinders and mixies at one more side, air conditions at one more side. These are all categorical data, wherein you are not able to measure against each other. There is no question of measurement against each other. So second type of data, what we have observed is categorical data. Third type of data is what is called ordinal data. What do you mean by ordinal data? These are categorical data but can be measured up against each other. So these are categorical data but can be measured up against each other. What is example for each? The example is, I'll take an example of a school. I'll take an example of a college. College is one category wherein you are measuring the quality of the college based on accreditation, NAC accreditation. So they say our college, so and so college, NAC A grade, NAC B plus grade, NAC B grade, NAC A plus grade. See, these are the categorical data wherein you can measure the quality. How do you measure? NAC A plus plus is a top grade college, next to which is NAC A grade, next to which is NAC B plus plus grade, next to which is NAC B grade, like this. So you can categorize the data based on the grading system. So the only difference between categorical data as well as ordinal data is categorical data cannot be measured. Like school and hospital, you cannot measure them. Hospital has got its own set of activities. School has its own set of activities. But among schools, there are some parameters which you can measure. What are the parameters? Oh, it's A grade school. It's a B grade school. It's a C grade school. So that you can compare the categorical data. So, three types of data. What we have studied now is, one is numerical data, which is split up of two different types called discrete data, continuous data, and another one is ordinal categorical data, and third one is an ordinal data. So these are the three important types of data. Right? Now we shall move to next slide. Now, what are the basic activities to the numbers we can do? Right? Basic activities, as I already told in the previous section, that your data may range from a simple list to a complicated data which is available in either Excel sheet or in database. Now let us see what are the activities which you can do on a simple numbers. So, on a simple number, we have got in ML three activities which are of interest. One is mean, which gives the average value, median, which gives a midpoint value, mode, which gives the most common value. Now, let us see all these things together. What is meant by mean? What is meant by median? What is meant by mode? So mean gives the average value, median gives the midpoint value, mode gives the most common value. Normally we use these things in mathematics, even in statistics also we use. I'll take an example. What is an example? There are 13 cars which are moving at a speed, at a different speed. There are 13 cars which are moving at a different speeds. What are the different speeds? First car is moving at a speed of 99 kilometers per hour. Second car is moving at a speed of 86 kilometers per hour. Third car is moving at a speed of 87 kilometers per hour. Next is 88 kilometers per hour, 111 kilometers per hour, 86 kilometers per hour, 103 kilometers per hour, 87 kilometers per hour, 94 kilometers per hour, 78 kilometers per hour, 77 kilometers per hour, 85 kilometers per hour, and 86 kilometers per hour. See, there are 13 different entries. The same thing I will analyze in a little different way. Here, example is given about the speed of 13 cars which are moving. But I will take this in a different way. How? I'm declaring a speed which is a list containing 13 different values. I'm taking speed as a list containing 13 different values. What are these 13 different values? They are the speed of 13 cars. Instead of simply mentioning a list, I am giving a new definition to the list. What is a new definition to the list? The new definition to the list is it is the application, means some real-time data. Of course, it's a discrete data. It's a discrete data. It's a real-time data. What is a real-time data? 99 is not a random number. Somewhere I didn't pick it up and put it. 99 is the speed of first car. 86 is the speed of second car. 87 is the speed of third car. Like this, I have drafted one. I have created one list of 13 data and give the name of speed. Now let me find out what is a mean. What does a mean? So, mean is nothing but average speed. So, what is the meaning of a mean? The mean is nothing but average value. So, average value, which includes the average speed of the entire 13 cars. So normally that is one real-time application. Normally to study the road, study the traffic density and all, people need what is average speed of the vehicle which are moving on the road. How do you find it out? We find it out by means of the mean. So how do you find the mean? We add all the data, divide by the number of cars. So here all the speeds are added and it is divided by number of cars to get 89.77 kilometer per hour as a speed. But instead of doing all these things, if you have a ready-made function, it's a mean. Ready-made function is available which is called a mean, for which we have to import a module called NumPy. Okay, we have to import a module called NumPy which has definitions for the various functions which we use here. For example, mean. How can we use mean? Mean is a function which will run and which is defined in the NumPy module. So, wherever we want to use mean, we have to import NumPy. This is one very important point to know. So, what I do is, as I told you, import NumPy. So, import NumPy because here x is equal to NumPy dot mean of speed is a function defined in this method called NumPy. So how do I find out? How do I find out? I am taking a list of 13 and I am declaring a variable x wherein one line is sufficient. NumPy dot mean speed. What is the speed? It's a list. So this one line is doing this activity. X is equal to NumPy dot mean of speed will do the above activity, this particular activity, then you will get the result as 89.77 and the result will be 10. That's on the program. See, 89.769230. It is possible to round up also. So speed is equal. Okay, I will now change the speed to say 110 and I'll run the program. Accordingly, say speed has changed. It was 89 earlier, now it is 90.30. So numpy dot mean is a ML tool, machine learning tool, to find out the mean of the list, for which we have to import a method called numpy. So this is a simple activity called numpy. Then next, median. What is the meaning of a median? Median value is the value which is existing in the middle of the list. After we sort all the values. I repeat the statement once again. The median value is the value which is existing in the middle. So thinking that can I find out the median for this? I cannot, because this is an unsorted list. So in order to find the median, I have to sort the data. And this, you just look at here. This is a sorted data. 77, 78, 85, 86, 86, 86, 87, 87, 88, 94, 99, 103, 111. So it is very important to note that you have to sort the list before you find the median. Here also you need to import the numpy. Just look at here. It's not sorted out. It is not sorted out here. Suppose if we sort it out, what will come? Let us see. If we sort it out, right? If we sort it out, actually it should be a sorted number here. The number is not sorted out. So as I told you, the median function requires the data to be in the ascending order. It's very important to note that median function automatically arranges the number in an ascending order, then it prints the middle value. This is a list which is not in an ascending order. So numpy dot median of the speed has two functions. First function, automatically it will arrange the numbers in an ascending order, and from that it will pick the middle value and gives a result. Now there is one issue. So here it is 87 which comes in the middle. Here it is 87 which comes in number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 means 11. 1, 2, 3, 4, 5, 6, 11. 7, 6 and 7. This point is going to the median value. Actually here 87 is going to come. For example 86, 86, 86, 3. Then 87, 4, 87, 5, then 86, 1, 86, 2, 86, 3, then 87, 1, 87, 2, then comes 88, then comes, oh sorry, 85 is that, I made a mistake. 85 will be the first element, then 86 is the second element, 87 third element, 87 fourth element, 86 it is repeated twice. See, 85 first element, 86 second element, 86 third element, 86 fourth element, 87 fifth element, 87 sixth element, then 88 seventh element, 18 8 seventh element, then we have 94 eighth, 88, 94. So if you arrange them in an ascending order, we'll be getting in middle 87 as a number. 87 will come in the middle as a number. Now suppose if the numbers are in even number. So I will run the same example. Say I will run the same example, but here instead of 13 element, what I do is I will add one more element. Say uh, say 96. I'll add one more element because count is equal. Count is even number. So count is even number. So in such case here also it is 87 plus 87 divided by 2. You are getting 87 only. But normally what happens is if the two numbers, if the total length, in this case it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in the middle you find these two numbers. When these two numbers are there in middle, then median will be the average of these two. If the numbers in the list are even, then average of the middle two numbers are taken to find out the median. So that is a median. Suppose if the number is odd, if the number of elements are odd, the middle one will be the median one. If the numbers of elements is even, then average of the first two numbers will be taken. So same example is given here also. Now coming to the mode. Coming to mode. What is a mode? Mode is a value which appears the most number of times. Mode is a value which appears the most number of times. Let us look into the example given. 99, 86, 87, 88, 111, 86 repeated twice, 103, 87 repeated twice, 94, 78, 77, 85, 86. So here 86 is repeated thrice. That is a most number of times. It's maximum. Maximum. Okay. So mode value is the one wherein in the list which number has appeared the most. In this example, 86, 86, 86. Three times it has appeared. So 86 is the answer. Now for this, we get the help of another module which is called SciPy, or SciPy, S-C-I-P-Y. A SciPy or a SciPy or a SciPy can be used for getting the help. So from SciPy, import status. This is the way. So I am importing SciPy, and here I am finding out, I am giving the same list, and I am finding out x is equal to status dot mode of the speed. Because SciPy is imported as a status here, status is a variable which will import the SciPy values. So I am using that to find out the mode of the list. So you will get the outputs, right? So mode is 86, count is 3 times. How many times? It has come, count is 3 times. For example, if I say, see, I'll use, okay, I'll use 86 once again. Then let me check out what is the answer I'm going to get. I'll run it once again. 86, it has appeared 4 times. I'll try with 87 because 87 also, now 87 and 86 are equal in number. Let's see how does it work. How does it work? See, it gives 86 only. 87, 1, 2, 3. So it says 86, which has appeared thrice. Okay, I will now make 87 once again. Now 87 should come. Will it accept it or I have to check it out? See, 87, 4 times. So, but suppose if there are double entry, it will consider only one at a time. 86 which is repeated thrice. So this is how we find the mode. So what we have discussed so far, we have discussed 3 points: median, which is average value, then mode, mean we have discussed, it's the average value, median, the value which is existing exactly in the middle, then mode, the one which has appeared more number of times. So these 3 are the items we have discussed.